Hi, so this is chain rule part 4. So we're just going to do some problems that are a little more extensive, just kind of building on the ones that we've done. So let's take a look at example 1. Notice on this one, it's the cosine of this. Okay? Now, what I would suggest is that you put another set of parentheses in here, because it's really 1 minus 4 theta is going to be done first, then it gets squared, then we take the cosine. So there's 3 parts to this, and it almost looks like there's just one parenthesis, but there's really an implied other parenthesis around the whole thing like that. So the first thing I'm going to think of is that this is cosine u. The derivative of cosine u is going to be negative sine u. Don't change the angle. So now I did the derivative of cosine, so I'm done with that. So now my problem becomes 1 minus 4 theta squared. So these parentheses are now going to be my u. So now I have to think of this as u squared. So the derivative of u squared is 2u. There's the u. So it's going to be 2u. So now we did the derivative of u squared. So basically I did the derivative of the squared. And so now I'm finally to the innermost part of the parentheses. So the derivative of 1 minus 4 theta is negative 4. Theta is just like an x. So now I can see I've got all this. I don't change the angle. This stuff right here is all I'm concerned about. So I have negative 4 times 2, that's negative 8 times a negative is going to be a positive 8 times 1 minus 4 theta times sine of 1 minus 4 theta quantity squared. It's just like you're trying to work your way inside. It's kind of like if you think of opening a gift. You know, you take off the bow, you take off the wrapping paper, you open up the box. Same kind of thing. We work from the outside in. Once we get to the innermost part, that's when we're finished, when we've taken that derivative. You know, sometimes people keep taking the derivative, like they take the derivative of this. What would the derivative of this have been? 0, right? It's a constant. If you ever get an answer of 0 on a chain rule, it means you've gone one step too far. You've taken too many derivatives. Okay? All right, let's look at this one. This one is a little bit difficult too. I'm going to put in some extra parentheses. This is just a rewrite of my problem. That's what that problem means. See, in order to do calculus, you have to understand order of operations. You have to understand that this would be done first, then we would take the cosine, so this is done first, then we take the cosine, then we're squaring, and then we would multiply by the coefficient. So to do this problem then, this is just a rewrite of the original. To do the derivative, here's my k, here's my n. I'm going to have to do k times n because this is really 1/2 pi u squared is what the problem is. My outermost parentheses, that's my u. So I do 1/2 pi times 2. Well, that's just 1 pi. So it's going to be just pi u to the first. Okay? So that's what I've got for that. So it's just going to be pi u to the first. Pi, here's my u to the first power. So now I'm done with all of this part. So now I'm down to my u. So if it helps, do this. Say I'm finished with that, I'm finished with that. So now I'm down to this. So now we're doing the derivative of cosine of 1 minus 4 theta. Well, the derivative of cosine of u is going to be negative. I'm going to put the negative out in front so I don't think it's a subtraction. Negative sine of 1 minus 4 theta. That's the derivative of cosine. Done with that. Done with cosine. So now I'm finally to the innermost part of the parentheses, and the derivative of 1 minus 4 theta is negative 4. So we have negative pi times negative 4. That's 4 pi. Now I have sine of 1 minus 4 theta. And I have cosine of 1 minus 4 theta. Does anybody notice what this is the same as? How I can do more with this? This is A sine U cosine U. So what can I use? Double angle formula. This is my A. I divide my A by 2. I have sine U cosine U. So it's going to be the sine of 2U. Okay? I think you had one kind of like that on your worksheet you just did. So if you got that one, that's awesome, because that's a lot. Okay, let's look at example 3. Haley, on number 3, what am I going to think of first? Am I going to, sine U is first. I would think of this as sine of 3x squared, and I would put one more parenthesis in there. It helps to put that other parenthesis in there to understand that the chain rule is going to have to be done once, twice, 3 times. We're going to take derivatives. Derivative of sine U is cosine. My outermost parentheses are the U. So I did the derivative of sine. So now I'm to this. Here are my parentheses. So now I'm thinking of it as U squared. Well, the derivative of U squared is 2U. So now I did the squared. So now I'm to the innermost part of the parentheses. The derivative of 3x is 3. And now I just put it all together. 3 times 3 is 9, times 2 is 18x. There we go. On the next one, purposely no parentheses were put in there to kind of force you to put the parentheses in there yourself. Think about it. How would those parentheses go on that problem? Anybody know? What is it, guys? Sine of what? 3x in parentheses. And then where do I put the squared? What do I need to do to have the squared? Yep, parentheses around this whole thing and then squared. So am I going to think of it as sine U or U squared to start with? U squared to start with. You start with the outermost parentheses. That's your U. Squaring it. So then y prime, the derivative of U squared is 2U. So I did my squared, done with that. So now I'm down to this inner parenthesis here. So now I'm thinking of it as sine U. The derivative of sine U is cosine U. I just did the derivative of sine, done with that. And now I do the derivative of 3x, which is 3. And I have 3 times 2, which is 6 sine. Got that? Does that look familiar? What's it going to be, Kyle? No? Good. 3 sine of 6x. Got it? Not too bad, is it? This is one of those things that you watch somebody else do it and it makes perfect sense. And then you're going to do it yourself and you're like, what do I do first, you know? So you got to practice. Let's finish up these last 2. Alright, so looking at this one, this is this quantity getting squared. So I would take the cotangent of that quantity. So I'm going to throw in another parenthesis just so I don't get confused about what my U is. So I'm starting off, it's 2 cotangent U. So the derivative of 2 cotangent U is negative 2. Derivative of cotangent, what is it? Negative cosecant squared. Good. You can look at your green sheet, or maybe you just remember that. Don't change the angle. So it's -2 cosecant squared of that angle. I just did the derivative of 2 cotangent. So now I'm down to this problem. So now I'm down to u squared. So the derivative of u squared is going to be 2u. Now I'm done with the squared. So now I'm on the inside. Derivative of 3x is 3. So now putting it all together, this angle doesn't change. I just multiply all of this. -2 times 2 is -4 times 3 is going to be -12 cosecant squared of 3x. Oh, I forgot that. Hold on. -12 3x minus 1 of cosecant squared of 3x minus 1 squared. Okay, because all of this is part of the coefficient. Don't change the angle unless you use a double angle formula. That's the only time the angle should look different, is if you're using a double angle formula. Okay, the last one. Rewrite it. That would be my rewrite. I got to do this, I got to take the cotangent, I got to square it, multiply it by 2. Outermost parentheses, that's my u, so it's 2u squared. So that derivative, 2 times 2 is 4, don't change the u to the first. So we just did the derivative of 2u squared, so we're done with the 2's. We already took care of those. Now we're down to cotangent of u. Derivative of cotangent we just did. It was negative cosecant squared of u. So now we just did the derivative of cotangent. Done with that. Finally, down to the inside part. This is when we're finished. Derivative of 3x minus 1 is 3. So we're going to have -12 cotangent 3x minus 1 cosecant squared 3x minus 1. Okay? Not too bad, right? Just got to work your way inside with that chain rule. You're really doing problems that are very complex problems. You're doing problems like h of g of, h of g of f of x is what we're doing. We're taking the derivative of that. That's a very complex function. Okay guys, good job. Make sure you do those problems out of the book.